You've seen them in the sky, those long white trails that seem to follow airplanes wherever they go. But what are they really, and why do they sometimes linger for hours while others vanish quickly? These are called contrails, short for condensation trails. They form when hot exhaust from a jet engine meets the cold, low pressure air at cruising altitude. The water vapor in the exhaust condenses and freezes into tiny ice crystals almost instantly. At 30 to 40,000 feet where planes fly, the temperature can be as low as negative 40 to negative 70 degrees Fahrenheit. That extreme cold combined with low atmospheric pressure is perfect for forming contrails, especially if the air already has a lot of moisture in it. This process is similar to seeing your breath on a cold morning. The moisture in your warm breath condenses in the chilly air. In a plane's case, the exhaust is hot and full of water vapor, and the surrounding air is much colder, instantly forming ice crystals. Some contrails disappear within seconds. That's because the surrounding air is dry and the ice crystals quickly sublimate back into vapor. But if the air is humid, the contrail can persist, sometimes expanding into wide cloud-like formations. These are called persistent contrails. The persistence of contrails depends heavily on humidity and altitude. If the air is near its dew point, those crystals stick around. If it's dry, they vanish quickly. Pilots and meteorologists use upper air charts to track this. In fact, modern aviation weather forecasting includes tools that predict where contrails are likely to form and persist, valuable for air traffic planning and satellite imaging clarity. Contrails vary with aircraft design too. Some jets produce thick trails while others leave nothing. This depends on engine efficiency, bypass ratios, and fuel type. But high bypass turbofan engines, common in commercial jets, mix a lot of cold air with a hot exhaust, increasing the chance of condensation. Military jets with low bypass engines often create narrower or shorter-lived contrails. Contrails aren't anything new. During World War II, bomber squadrons left dramatic trails across the sky, sometimes giving away their position to enemy forces. It's one of the earliest recorded tactical considerations related to contrails. Jet fuel, typically Jet A or Jet A-1, is mostly composed of hydrocarbons. When burned, it produces carbon dioxide, water vapor, and heat. That water vapor, mixed with existing moisture at high altitude, can lead to contrail formation. There are actually three types of contrails: short-lived, persistent non-spreading, and persistent spreading. The last type is what often leads to hazy skies and cloud-like layers. Apps and tools used by aviation enthusiasts and meteorologists can show which flights are currently producing contrails based on altitude and weather data. It's a great way to explore contrail behavior in real time. A time lapse over a few hours can reveal just how many aircraft leave trails in a given region, especially over major air corridors in the US, Europe, and Asia. Understanding contrails also means understanding how the atmosphere changes with altitude. As you go higher, the air gets colder and less dense, both critical factors for ice crystal formation. Lighting conditions also affect how visible contrails are. At dawn and dusk, low-angle sunlight illuminates the trails more dramatically, making them appear more vibrant and colorful. At the microscopic level, each contrail is made of millions of tiny ice crystals. These form around particles in the exhaust, such as soot or metal traces from turbine wear. These particles act as a nucleation site for ice. Not all trails are from engines. Under the right conditions, air flowing over wings and flaps can also condense into visible trails. These are called aerodynamic contrails. Wingtip vortices create areas of low pressure that cool rapidly, sometimes enough to cause condensation. These effects are brief and usually only occur during takeoff or landing. So, to sum up, contrails are not just puffs of cloud. They're complex, fleeting, and fascinating outcomes of chemistry, physics, and weather dynamics, triggered by powerful machines flying miles above us. The next time you look up and see those streaks stretching across the sky, take a moment to appreciate the layers of science involved in that simple white trail. From fuel combustion and thermodynamics to humidity and wind patterns, it's all there, high above, silently tracing the invisible structure of our sky.